This image is in downtown Calgary, Alberta, Canada. And in this shed is a stage recorder that's been monitoring the level of the Bow River in Calgary since 1911. These stage recorders, these hydrometric gauges, are the source of conventional data for water management and engineering. All analyses of water supply, water allocation, storage, conveyance, all the conventional water resource engineering is based on the use of gauge data. In Canada, the federal government maintains a network of more than 200 gauges. You notice that there is a heavy concentration of gauges along the border with the United States. That reflects the fact that 90% of Canadians live within 150 kilometers of the US. And the reason that this network was established in the first place was certainly not for scientific purposes. This network was created to determine where the water is. Initially for transportation, for the steam locomotives, and then for agriculture, for the purpose of irrigation, it was necessary to know where there was water. And so that was the rationale for this network. And as a result, the number of gauges that have been operating for more than 50 years is 40. Okay, so of this network of more than 2,000 gauges, only 40 have been operating continuously for more than 40 years, which is, of course, a serious constraint for analyses of trends. I thought that was my phone for a minute. The analysis of trends and variability in hydrology, this represents a serious constraint. And at least in our case, one of those gauges is on the Bow River near Calgary. And the record looks like this. This is the Bow River at Banff, Alberta. A large amount of interannual variability, above and below a trend of declining flow. That trend, shown in red, is a reflection of the loss of mass of natural storage, the loss of glacier storage and permanent snowpacks in the Rocky Mountains of Alberta. But there's another scale of variability here. There are periods of 20 to 30 years of higher flows and periods of 20 to 30 years of lesser flows. This low frequency variability is becoming apparent in these instrumental records because they are achieving a length of 100 years in Canada. However, even this record, this is the longest record, continuous record in all of Canada, and it only captures less than 2 cycles of this low frequency variability. And as a result, for the analysis of this scale of variability, of course, it's necessary to introduce paleo hydrological data. And there are research groups throughout the world, research groups in dry river basins on just about every continent, except Antarctica. Notably, for example, probably the most prominent group is working in the Colorado River Basin for many decades on the tree and reconstruction of the Colorado River. In our case, we work in Western Canada. This is one of our sites. This is an open canopy forest of Pinus flexilis, limber pine. The student here, this is Jonathan Borichevich from Valdivia, Chile. And we have just extracted a wedge of wood from this standing dead tree. These limber pine are in excess of 1,000 years in age, so we have a millennial chronology. And it's very much moisture sensitive. You can see it's a dry site, dominated by a single species of tree. And as a result, we're able to reconstruct stream flow, drought, groundwater. Our network circumscribes the Prairie ecozone of Canada. This is a land cover map of North America. The international boundary separating Canada from the US is approximately right through here. And so the Great Plains of North America extend well into Canada, and this is the grassland of Canada. And so our network of tree and chronology circumscribe that region. There's the red box. Our longest chronologies and our most significant chronologies are from the eastern slopes of the Rocky Mountains in Alberta. Here is the front range of the Rocky Mountains, and these, we call these foothills, and in this case these foothills are occupied by fescue prairie and montane forest. And the montane forest consists of Douglas fir and limber pine in this case, which approach 1,000 years in age. And also it's an open canopy forest, so it's very much moisture sensitive. And therefore we're able to construct stream flow. So this is a reconstruction of the Low River back to the year 1107 in Calgary. These are stream flow anomalies. A positive anomaly is blue, a negative anomaly is red. It's published, so I can send you the PDF if you'd like. We also analyze these sequences of tree ring chronologies. In this case, a paper that's just been published, it's online in Water Resources Research, where in a moving window, we analyzed central tendency, dispersion, and persistence using an index called Shannon entropy. So I will refer you to this paper as well. We're able to reconstruct groundwater levels. In fact, if you can read this slide, in this case, the R squared, the explained variance is 71%. And this is adjusted for the tree ring predictors. And so our highest correlations are with groundwater levels, which is not surprising because, of course, the trees are using soil moisture, which is contiguous with the water table in the case of shallow groundwater. So using well water information, this is an observation well in Alberta. We're able to calibrate and validate the tree ring record. This is the high frequency variability, and this is a running mean. And this is a reconstruction of the Palmer Drought Severity Index using principal components. So a principal component of a group of chronologies and a spectral analysis of this record. This is a record of PDSI back to the year 1406. And the multi-taper method spectrum shows significant modes of variability in the ENSO band, in this case 2 to 4.5 years, but also significant mode of variability at around 60 years. And the wavelet spectrum shows the persistence of this cycle at about 60 years, which corresponds to the frequency of the PDO. And also those wet and dry phases in the flow of the Bow River and Calgary. And we published a paper a couple of years ago where we noted the very strong correlation between the PDO index and the flow of rivers in southern Alberta. And so we posed the question, are the current trends in the gauge record, do these reflect global warming? Human impacts in terms of diversion and use of the water, or natural modes of variability. Now I'm kind of glossing over the science because I want to get quickly to the applications. One more paper we published recently where we argued that if the PDO was such a strong control over water levels in this part of the world, then when we are developing climate change scenarios for the future, we have to make sure that we use climate models that are able to simulate the PDO. So this PhD student, she mapped the pattern of the PDO in the North Pacific, and then a series of GCM experiments, and she only chose those, she identified those that were able to replicate the PDO pattern. And so when we develop projections of future climate, we use those models that are able to replicate the PDO. We develop projections often because our tree ring lab is based at a climate change adaptation research center where we have a mandate to inform government, industry about the impending climate of the next several decades. And another part of our mandate at PARC, the Prairie Adaptation Research Collaborative, is climate science outreach. where we respond to requests for climate change information, including talks, and as a result, over the past 10 years, I've been asked to give more than 300 talks on climate change to professional societies. I'm going to show you the most recent 10% of those talks. I'm just going to scroll through them. And I want you to notice that I've highlighted the audience for the professional society. Farmers, engineers, farmers, the health professions, watershed societies, farmers, First Nations, Canadian Indians, vegetation managers. But for the most part, we speak to farmers and ranchers, the people that manage the landscape. Here is a recent meeting. There is some group of PhD students, 4 PhD students at the back, doing what they're supposed to do, taking notes and recording the session. This is a group of farmers and ranchers, and we are presenting them with a lot of climate information, maps, charts, and so on the table, and then we ask them, if these climate conditions were to occur in the near future, what would be your adaptive response? How would you deal with drought and excess water, conditions that you have not experienced in your lifetime because you've only been farming for, say, 30 or 50 years? And so we have a lot of these sessions, and the response we get is fairly interesting. We also encounter farmers and ranchers in the field because most of our sites are on private land. And we get a lot of cooperation. In this case, we are setting up a climate station last fall. These 2 students, these are PhD students from the Czech Republic, from Brno, and they're coming back to Canada next month because we are going to monitor on a weekly basis the climate conditions at these sites, and they're going to resample the Douglas fir and Nimber pine on a weekly basis. And so they're going to study the response of the trees to weather at weekly resolution and cellular resolution. It's a convergence of methods of dendroclimatology and xylogenesis. But the reason I want to use this slide is because this cowboy here is taking very much an interest in our research. This gentleman is responsible for managing a cattle ranch. That ranch is 25,000 hectares, 10,000 head of cattle, and much of our sampling is done on this ranch, and he gives us a lot of help, including building a fence to keep out grizzly bears and cattle from destroying our climate station. And in the course of working for 2 days with people like this, we get lots of insight into the weather and climate. One of the things they tell us is that when they go to bed at night, they check the weather forecast. When they get up in the morning, they check the weather forecast. And they find that the precipitation data, the gauge data, is typically unreliable because these small cylinders are trying to capture the rain. And what they tell us is when we present them with tree ring data, they find it more reliable than the precipitation data. And after all, these people are in the business of growing crops and grass, and the tree is a plant as well. And so the information in the tree rings is more relevant to them than is captured by a small precipitation gauge. Also, the weather that they experience is not just the high frequency variability from year to year. It was falling and falling and falling. In the background are houses that were built on the lakeshore during the previous phase of the PDO, wet phase. PDO flipped into a dry phase, and the people lost their lake, and they blamed the government, they blamed the farmers, they blamed everybody except the PDO because they don't know about it. The PDO, there's a consensus that the PDO flipped again in 2008, and ever since 2008 we have had wet conditions, such that now some of the roads in our region are underwater and some of the tow trucks are stuck. So we can expect primarily wet conditions. Now, this kind of climate variability has its costs. This is a database maintained by the Government of Canada, 817 climate disasters in the history of Canada. The most costly disasters in the history of Canada are drought in the Prairie provinces. And a recent drought A drought in 2001-2002 came at a cost of almost $6 billion. And that's because more than 80% of all the farmland in Canada is in what's called the Prairie provinces in the middle of the country. And so every time we get a drought, it affects the entire economy and food supply in Canada. In our part of the world, we now produce a lot of lentils. Most of the lentils that are exported in the world, to Bangladesh and Sri Lanka and India, come from the Prairie provinces. Because we don't eat lentils, but we grow them. So that's the reason that drought tends to be so costly. Here's the region I'm talking about. This dry tone here, this represents the non-contributing area. That area produces no water. It's too dry. And so to sustain an economy, it's necessary to use the water that comes from the Rocky Mountains and it flows through these rivers. And in the last 5 minutes of my talk, I'm going to give 5 examples of the use of our treating records for the management of the South Saskatchewan River, including the Bow and Oldman tributaries, and the North Saskatchewan River. The South Saskatchewan River, following the drought of 2001-2002, the government of Alberta closed the basin. It's no longer possible to get water, get a license for water, which is a bit of an adjustment for people because people perceive Canada as having an abundance of water. It's true Canada has a quarter of the world's fresh water, but it's locked up in ice caps and glaciers and large lakes where people don't live. Where the people live, there's an absence of water, and so the government closed the basin. And the data they use, in order to justify that action and explain it to people, they use our tree rings. So here's a reconstruction back to 1406. And the way that they present, we didn't make this illustration, the government did, the way they present the information is that they take our reconstruction and divide it in half. And that's because this river crosses borders, and Alberta is able to keep only half the water. There is a government agency called the Prairie Provinces Water Board that ensures that Alberta only uses half the water. And this agency also is using our tree rings. They want to know how robust is this legislation giving multi-year droughts. And so they've asked us to reconstruct the flow of these rivers at the provincial boundaries and the international boundary using our tree rings. And we're in the process of doing that. Another example, the Ministry of Agriculture has this program called Extreme Climate Event Preparedness and Adaptation. It includes an innovative program called an Invitational Drought Tournament. This tournament, where they get water managers competing with one another to deal with drought, is quite innovative. There was just a tournament held in Colorado. So the Americans want to adopt a similar competitive approach to developing adaptations. But the original tournament was held in a hotel in Calgary, Alberta, where they had teams of expert water managers competing for prizes by coming up with the best solutions for dealing with drought. Where did they get the drought scenario? From the tree rings. So they asked us to take our treating record and develop a scenario. We used Markov chains, we used Monte Carlo analysis. They need to tell these people, these water managers, the probability of having drought in the first year, the second year, and up to 5 years of drought. And so we did that using tree rings. A fourth example, working with the city of Calgary. The water supplies from the Rocky Mountains in the distance. The city of Calgary has doubled in size since the Olympics were held here 25 years ago this week. And so this is a rapidly growing city and is concerned about the sustainability of the water supply. So we thus reconstructed the flow of the Bow River for the city of Calgary. We're working directly with the city, but also the city is part of a consortium that's looking at the allocation of water within the basin. Mostly these people are engineers. They like to use what's called exceedance probabilities. And so we take our tree reconstructions and we develop these exceedance curves, because engineers aren't familiar with looking at paleoclimate records. They are familiar with looking at these. And so an exceedance curve uses the tree rings. Exceedance curves based on an ensemble of climate models, and an exceedance curve based on the gauge record, the historic flows of the river. And so for the same exceedance probability, we can tell them what is the water level at that probability from the tree rings, from the gauge, and from climate projections. Also working with a stochastic hydrologist who says, you know, in stochastic hydrology, we develop these synthetic, hypothetical time series of thousands of years of flow, but nobody's tried to do that using tree rings, where this synthetic time series has the statistical properties of the tree ring record. So he thinks he can derive weekly flow estimates from our 1,000 years of water levels inferred from the tree rings. We'll see. And the last example, this is the agency that manages the North Saskatchewan River. And it's about several hundred engineers who do this. And what they told us was they know how much water's in the river. Assuming, of course, that the gauge record is representative and that it's stationary, which it's not. So we gave this corporation a reconstruction of their river back to the year 1063. They weren't sure how to use it because they're engineers. But once given enough time to reflect on it, they thought this was pretty cool, and they asked me if they could present this at an engineering conference. And this is the second to last slide. This is the abstract from a presentation given by engineers. I'm going to work from the bottom up. Yeah, we gave them a 1,000-year record. This is the source of the record. This 1,000-year record lets them assess future risks to the water supply. But this jumped out at me. Water utilities, including EPCOR, are revisiting the assumption of a static water supply. And I thought, wow, if we achieve nothing else in our careers, if paleoclimate records convince engineers that stationarity is a bad assumption, then we've achieved our objective. Thanks.
Thank you very much, David, for this very nice overview, and also I think this is a very good example of how to engage with local communities and stakeholders. I'm really impressed by that. The talk is open for questions. Heinz.
And also for this application examples. In Central Europe, we realized that it doesn't help if we send Al Gores or professors to the TV. We have to send shepherds, farmers, or mountain guides talking about climate change. Have you ever sent a cowboy to TV or in order to discuss climate change? Because sociologists have shown that the effect of such people talking about climate change in TV is much higher than if professors or directors of weather services are talking about it.
Mm-hmm. That's our experience as well. We actually do that. And that reminds me, there's one talk to a public audience about 12 years ago. Afterwards, a senior government official approached me and said, "Nice talk, Dave, but never, ever start a talk with the climate model." He said that half the audience doesn't believe it, and the other half don't understand it. He said, "Tell them the tree ring story." And so the next 299 talks that I've given have started with the tree rings. And everybody likes it. Everybody knows the story of tree rings from their youth. It's tactile, it's concrete, and so we use the tree rings as a means of, it's a gateway. It allows people to be comfortable with the concept of climate change using tree rings, and then you hit them from behind with the climate model.
Okay.
What kind of base legs one would expect? with the tree ring record with the precipitation record or the groundwater changes. There has to be certain phase lag. There
Yes.
should be.
Yes.
What kind of phase lags you're talking about? Because when you are going to predict for the human time scale for 4 years, 5 years, these phase lags will be important.
Yes, in the case of deep groundwater levels, there's a long lag, but so our reconstruction of groundwater is only using shallow groundwater within meters of the surface. And with stream flow, if there is storage in the basin, for example lakes, then there's a lag. But this is a dry climate, so there tends to be a short lag between the peak stream flow and the tree rings. Hope that answers your question.
Thank you very much. You are very illuminating talk. You said that this drought variability, interannual variability is related to ENSO. Is this relationship stable over time?
Pardon me, sorry, the last part?
ENSO variability
Yes.
is related to interannual variability in drought is associated with ENSO.
Yes.
Is this relationship stable with time?
That's a good question. In our PDSI reconstruction back in 1406, and there are many independent reconstructions of ENSO. And so we've compared our reconstruction with many other reconstructions of ENSO. And for the most part, our droughts occur during the El Nino phase. And, but these are not stationary, they're not stable. So you can see in the wavelet analysis, in that the wavelet analysis in the time spectrum, that the strength of the PDO and the ENSO vary over time.
There's another question over there.
Thank you very much for that talk. I think it's exactly what managers should be involved with. I'm slightly puzzled by our chairman's remarks earlier about this not being central to paleo science, and I'd like him to explain himself. But my question to you is, the tree rings don't pick up the extremes of floods, for example. Have you ever tried to combine what you do with, say, the sort of paleo flood sedimentation?
Microphone's off.
So,
Where have you switch it on?
You want to use mine? Here, you can speak into my chest.
People might get the wrong impression. I do apologise. Look, this is exactly what I think pages should be involved with, and as I've already challenged the chairman to explain his remarks at the beginning about this not being central to paleo science, I simply don't understand that remark. So my question to you is have you ever tried to combine the tree ring reconstructions with estimates of flood events, which you don't get out of tree ring data, because water resource engineering and water resource planning, crucial as your work is, it's also concerned with extreme events.
That's right. The tree rings are not a good proxy of excess water. The response of tree rings to water is non-linear, and typically tree rings underestimate trees don't use so much water, and then other factors become limiting. So we tell the water managers, we can give you drought or flood, not both, which would you prefer? And they always say drought. They say if there's too much water, we just open the gates and let the water go. Drought, no, it's a whole new set of adaptations and strategies are required for drought. So that's really the big challenge. But also, yes, we do work with sedimentologists. There is a difference in terms of the resolution of the proxy. Because like I said, we're now developing seasonal stream flow reconstructions, and working with the Czechs, we want to have weekly resolution in our tree reading record. And so we've been working with sedimentologists looking at glacial lakes, where if there's a excess of glacial runoff, there's a change in the grain size in the sediment column.
Okay, thank you very much. With regard to the remark, I think there was a complete misunderstanding. We settled that later. But